Hello students and welcome to this calculus lesson. In this video, we're going to cover the properties of definite integrals, how they can help you solve some problems a little bit easier, and so that you can work with these definite integrals a little bit easier in the future. So let's get started. So what I want you to do is we've actually kind of been working with some of these definite integral, like some of these properties in the previous videos in lesson 1 and 6.3 as well. So what I want you to do is see if you can kind of identify what these are going to be equal to. Are you able to use your reasoning from the concepts of integrals that we've already learned about? Remember, it means area between a curve. And what I want you to do is see if you can say what these are, and I'm going to write them here in just a moment. All right, let's go ahead and discuss these. So our first one, since we have no change in that x value from a to a, that means we're not going to have a base on those little rectangles. So that means that the area is going to be 0. Now, if you have a line from a to c and like you have a point in the middle, or from a to b and you have c in the middle, like in number 2, then you can split up your integral. You can go from a to that midpoint and then midpoint to that final endpoint b in this case. One thing that's very important in number 3 is if we know what something is equal to, but then we flip the bounds, like we're going from a to b and then we flip it from b to a, that just makes the integral negative because you're going in that negative direction. And for the same thing, that's pretty much the same thing happening in number 4 here. If we switch from a to b and we go from b to a, then we just make the integral negative. Whenever you swap those bounds, you're gonna go and make the integral negative. And that can be helpful in some cases. One thing to note is that if you know that we have a constant multiple, you can just move that outside of the integral, and then whatever, you can just make this calculation however you normally make that integral. You do want to note that when you're working with polynomials, that you can just do the integral over each of those terms, such as f of x plus or minus g of x. But please keep in mind that this, kind of like derivatives, this does not work if you have multiplication or division. Those are going to be separate rules. And there's some interesting scenarios here in 7 and 8. If we have something that's an even function, we're going from like negative a to a here. Well, think about what happens in that area. Well, it's just going to be double because we have that y-axis symmetry. So we just know, like, if we can go from negative a to 0 or 0 to a, you just double it and you're good to go. And that's kind of what happens here in 8. If we're going from negative a to, let's say a is right there, well then anything that's above the x-axis is going to get canceled out with everything that's below the x-axis. So now we're going to move on to some of these examples, and this is very typical of AP calculus problems, is that it'll give us what some of these what some of these integrals are equal to. And you're going to have to use that information to figure out, using these properties of integrals, to figure out what those other integrals are equal to. And so this can really help solidify how you can interact with these integrals. I really kind of think about it as like a lot of algebra work. So as we're doing here, the first one, it says 3 to 0. I don't have, neither of these integrals are going from 3 to 0, but I do have this first one that's going from 0 to 3. So if I flip this, then I know that it's just going to make the integral negative. So now I'm going from 0 to 3 of f of x dx. And look, we have that up above. We know what that's equal to. We know that the integral from 0 to 3 of f of x dx is equal to 6. So I'm going to keep that negative, and I know that it's equal to 6. So the answer comes out to be negative 6. And that's how straightforward working with properties of integrals are. Now in this next one, in the second problem here, we have 0 to 7. And again, none of my integrals that are given are 0 to 7. But I do have 0 to 3, so I can split this up. I can split this up going from 0 to 3 f of x dx. And I can add it with the integral that goes from 3 to 7. So then what's happening is I go from 0 to 3, figure out what that chunk is, and then I go from 0 to 7, figure out what that chunk is, and I just put them together. So 3 to 7 f of x dx. All right, and I'm going to add these together. So I'm going to have 6 plus a negative 8, so 6 minus 8, and this is going to come out to be negative 2. So what I want you to do is go ahead and finish these problems and see if you get the exact same answers that I do. No waking up beside you and holding you till we forget it all. How could I know there was no second chances? Like dominoes, my life got really scattered. All right, let's go ahead and look at these answers. So in this third problem here, we're going from 3 to 3. So whatever happens, that area under the curve is always going to be 0. So that's going to be an important one to notice. Over here on the one on the right, all I did was take out that 3 as a constant multiple, and then I flipped the bounds of integration from 7 to 3 to 3 to 7. But as I do that, I have to make it negative. So make sure that you do make it negative and you get 3 times positive 8, which is 24. Over here, what I did on this fifth one is I did keep in mind that what I wanted to do was I'm still finding the integrals. So I do know how to find the definite integral from lesson 6.3. And all I did was find the antiderivative of 2, which is going to be 2x. And then I did my fundamental theorem of calculus there. So 2 times 7 minus 2 times 3, you know, just using the bounds of integration. And then when I had the f of x dx, all I did was grab that from the functions given above. On this next one, an even function, that's just going to double it. So you just need to find 0 to 3. And then over here on the last one, what we did was we had an odd function. I kind of just wrote it out, but since we know it's an odd function, we know that the bounds of integration are opposites to each other, -3 to +3. We know that it is going to come out to be 0 no matter what, because it is an odd function. So over in our next video, what we're going to do is we're going to finish up this lesson by going over like how we can use the concepts of definite integrals and what integration means to kind of solve some more obscure problems when it involves some geometric shapes. But as long as you understand what the concept of an integral is, that concept, that problem is not going to be an issue for you. Of course, if you didn't get any of these answers and you do need help, you guys do know that you can reach out to me. I'm always here to help. My name is Mr. Hernandez, and this was Mr. Hernandez Teaches.